Good afternoon to everyone present here on this wonderful occasion. I welcome you all to these informative sessions on basics and recent trends in R&DC. Now I welcome Dr. V. Sivakumar, Assistant Professor, Mechanical Department, to deliver the welcome address.
Good afternoon to all. I hope so my voice is reachable to all. Um, on behalf of Department of Mechanical Engineering, Ramco Institute of Technology, I welcome all the participants from various parts of our nation. So we are having the habit of enriching our students' knowledge through our professional societies. Uh, Especially three professional societies, especially dynamic societies like RIT-ISHRAE, RIT-IEA, and RIT-IAC joined together and organized this webinar on basic and recent trends in R&DC. The chief guest to deliver this content is Dr. P. Balachander sir, Assistant Professor, R&DC Division, Department of Mechanical Engineering, Anna University, Chennai. Nowadays, in a new dimension, the faculty community meeting their fellow students and transforming their knowledge to them, especially online mode. In this busy schedule, over a mail, Dr. B. Palachandar sir expressed his acceptance to deliver this content in this forum by this time. I wish the entire team who working began to get the fulfillment through this event. I welcome you all on behalf of Department of Mechanical Engineering, Ramco Institute of Technology. I welcome all the participants to this event. Over to Isagi Iswar.
Thank you, sir. Now I would like to introduce the resource person who has made himself available to enrich our knowledge. Dr. P. Balachandar is now working as an assistant professor in R&DC division under Mechanical Engineering Department, Anna University, Chennai. He completed his UG in KSR College of Technology under Mechanical Engineering specialization in the year of 1999. He then completed his PG course in Anna University in the field of refrigeration and air conditioning in Anna University in the year of 2004. He then did his PhD in Anna University under the specialization of flow boiling heat transfer in the year of 2013. After completing his UG, he worked as a site engineer in Metropolitan Equipments and Consultant Private Limited for a duration of 3 years. Then, after completing his PG, he worked as a lecturer for a duration of six years. Then, finally, he is working as an assistant professor in Anna University from July 2010 to till date. His major research contribution during his PhD was on the field of flow boiling heat transfer. He published 4 international journals and 1 national journals. He has participated in 2 international conference and 3 national conference. His expertise lies in thermal engineering, R&AC, cryogenics, industrial refrigeration, food process and prevention, heat transfer, thermodynamics, and computational fluid dynamics. It is such an honor to have an intellect mind among us today. Now I request the chief guest, Dr. P. Balajantar, to enrich us with his knowledge.
Thank you, Iswaran and Sivakumar Veer, and also other faculties present in this meeting, and also for the Ramco Institute as well as the ISHRAE, which has given me an opportunity to interact with the students. Thank you, one and all. I hope my voice is clear, fine. And as of now, I have some 72 participants. I'm very happy to give my the presentation as well as some share my knowledge which I have in the R&DC field. So before that, I need to get some information, that audience information regarding how much students are in second year, third year. Can you raise the hands who are in second year, something, so that I can have some idea about how depth I can go for about the presentation. I can understand. Can you raise your hands? I hope everyone is in their native place or in their own home and joining this meeting. I just want to, otherwise Sivakumar can inform me with
Yes,
respect to the participant, how much, how many second years and how many third years are there?
Yes, sir. Yes, sir. From Ramco Institute of Technology, in this forum, and 23 second year students, and then 14 third year students. As of now, they are available inside, sir. Apart from this, the through RIT IEA and RIT ISHRAE, we have invited other participants from other sectors also, sir. People from industry, people from other academicians also took part here, sir.
Okay, okay,
Yes, sir.
okay, okay. Thank you, thank you. Thank you, Sogma. Thank you. Okay, I just basically this presentation is exclusively for the students, just to know better understanding about the refrigeration conditioning in that field, as well as with that respect to the technology available in the R&D field. I will be presenting quickly so that more interaction I want to have with the students. And if you are not interacting, I'll put some quiz program, and then I'll complete my session. Fine. I hope my screen is visible. Okay. My time starts now. What is it? 35. So the refrigeration and air conditioning, one of the, I hope it is one of the, now even the pandemic situation, it was able to survive. How I am saying this one, this field is able to get this, the jobs from the, in our PG students are being put up in few jobs, that is in spite of pandemic, the jobs availabilities are there, career opportunities are available in various sector of the R&D field, like that R&D industries we have. It is a vast field. Everywhere it is R&D that is part is being is necessary. Either it is a residential or it is a commercial, whatever may be. This field is being intruded in all the parts of the societies. Okay, so that it is being given a major importance in present scenario. Future also, this R&D will be playing a major role. So that means you need to understand basically how this is being working, as well as if you want to have some PG level as well as some PhD, and that will be help you a lot in different area. The R&D is nothing but just there are trending areas which comes into the renewable sector, that is renewable energy sectors. In that also this plays a major role. I'll brief about those things. Okay, this refrigeration and air conditioning both are same, and it's nothing but with respect to the application wise, it will be different. Something refrigeration is majorly concentrated on the temperatures, and that is temperature. In that context, they will be saying it as refrigeration. If this temperature, moisture quantity, moisture content, as well as quality, as well as the velocity, all those parameters, if it is being involved, then that part, that idea can be called as air conditioning. But both refrigeration and air conditioning, it works on the same principle, same equipment. Okay. There is nothing that for refrigeration some one type of component, and the air conditioning different type of component. Nothing is there. Additional component will be there. Apart from this refrigeration, if you want to have some industry, that is some, what is that? The basic four components. That is, I hope you know the basic four component, which will play the major role in producing the cooling effect. That application wise only it is different. Okay, fine. Then the unit of refrigerations, it is generally called as a tonnage of TR or tonnage of ton, TON, I think so. Otherwise, then it is in terms of BTU per hour, it will be given in industry side, it will be, they will be saying. Otherwise, our SI units, if you want to convey, it's nothing but in terms of kilowatts, they will say. It's around 3.1 TR is nothing but 3.5 kilowatt. That is, the meaning is 3,500 watts amount of heat I have to remove from the space which need to be cooled. That is the base idea. 1 TR or 2 TR or 10 TR. It is nothing but how much heat that has to be taken from the space by the device. Okay, by the equipment which we are going to install. That much amount of heat has to be taken from the space. That is nothing but the tons. We will be calling it as tons. Fine. See, any clarification from my side when I am speaking also, you can interfere. Please interfere. And if anything, if I am making some wrong statement also, you can point it out. Okay, fine. I hope you know these major components of the these refrigerations or air conditioning, water maybe. These are the major component. Can someone read on behalf of me? What are the major components? Can you see it and tell me, the students? I need interaction.
Sir, compressor, condenser, metering device, and evaporator.
Good. Can you give a brief about what are the functions of these major components? Compressor, that is the major functions. What it does? What it will do?
Sir, it is used to raise the temperature and pressure of a refrigerant, sir. Vapor refrigerant, sir.
Good. Super. Okay, fine. Next about condenser and evaporator.
So it is to remove the heat from the condenser and converting its medium, sir, vapor to liquid state, sir.
That is a condenser. Okay. What about evaporator?
Sir, evaporator absorbs the heat from the refrigerant, sir.
Super. Okay, fine. From where it is absorbing? The heat from where it will be absorbed by the refrigerant?
Sir, conditioned space heat, sir.
Good. Super. Thank you. What's your name? Good.
Sir, Lakshman.
Super. I hope you are having more knowledge about the basic things. Okay, fine. So these are the major components, that is compressor, condenser, that is double C, double E, sometimes they will be calling it as, that is compressor, condenser, expansion device and evaporator. So main functions, that is compressor is just to raise the pressure. So in all this, either the whatever may be the tonnage, there are two pressure will be maintained. One will be the higher pressure and another will be the lower pressure. So the compressor is the component which does the function for maintaining the higher two pressure. That is one side you will have high pressure, that is condenser, and you will be put up in the high pressure side, and the evaporator will be in the low pressure side. And we have the expansion device where that does the function of lowering the pressure, and thereby the temperature also gets dropped down. That is the major function of the these four components. So okay, that is here we have condenser and evaporator. We have different types. Fine, you will see that one. Okay, fine. So here I just want to show you that is the two pressure exist between the in between the components. Okay. That is the condenser is always in the high pressure side and the evaporator will be always in the low pressure sides. And compressor does the functions that is raising the pressure. Actually, it will be, that is the liquid, that is vapor will be converted in, that is the vapor. I hope everyone understand this one. Fine. You see, initially you have suction line where this evaporator, the heat will be absorbed. See the fluid which is working fluid here, they will be calling it as refrigerant. In general, it will be called as refrigerant. Okay, this refrigerant that is present in the liquid, it will be in the liquid state where it will try to absorb the heat from the surrounding or the ambient where we have to take up the heat. Okay. Then the refrigerant, it will becomes liquid, will be converted into vapor. That vapor will be getting into the compressor. The compressor does the function of compressor. It will maybe different types of compressors are available. That it will pressurize the refrigerant from low pressure to high pressure. So that high pressure refrigerant will be at a high temperature, and so I have to recirculation has to be done. Okay, for that purpose, the refrigerant, what we are doing, we are putting a component heat exchanger where does the functioning of condensing the vapor into liquid. and we are just removing the heat from the refrigerant. Here condenser, we are removing the heat from the refrigerant, and evaporator, we are adding up the heat. Okay, that is the main function of the condenser and evaporator. So once if you remove the heat, that is from the it will be in the two-phase state. Here you have the it will be converted in from superheated state. It will be in two-phase state. It will come to two-phase state, and then it will be a subcooled, even sometimes subcooled state. That will be taken the change of phase. That is a change of phase occurring in the condenser, where at the end you will have only liquid will be present in the at the exit of the condenser. Okay, if proper proper functioning of all the component happens. Then we have the expansion device. Mainly it is nothing but pressure reducing valve. Okay, where it is reducing the pressure, we have different types of expansion device, and thereby the pressure and as the reduces, temperature reduces, and then the liquid the low temperature liquid is being produced in the evaporator. Okay, it is a continuous process. Fine. It's just for the students, those who are not aware of this, the component, and for that I am explaining this one. Okay, so you can see the picture idea here. They have shown the some what is the pressure or temperature that may exist in a refrigerator. Okay, you can see this one. Initially, the compressor inlet, you will have something like a inlet, you have something like 0.8 bar. 0.8 bar, the pressure is being raised to the 7.8 bar. So the pressure is being raised. You can see that the temperature, it is around 2 degrees centigrade, initial inlet to the compressor, and it is around something like 60 degrees centigrade, the outlet temperature of the refrigerant. Here it is the refrigerant. Okay, fine. Here then it comes to the condenser, where you can see this from 60 to 60, it is being brought to the 32 degrees centigrade. It will be nearer to the ambient conditions. The temperature at the exit of the condenser, it will be nearer to the ambient conditions. So this 32 is nothing but the saturation temperature of the refrigerant, which is around, here you can see that's around 7.6 bar. At that saturation pressure, this temperature will be lying. Okay. It depends upon the refrigerant which we are using. Probably if it is at 134A, the 7.6 bar, it is around 32 degrees centigrade. So this is the at the outlet I am getting it, and which is moving into the expansion device. Here you have the expansion device, where that you can see around there is some reduction in the pressure, and there it is at the temperature is around here it you have at the entry you have something like a 24 degrees centigrade. At the exit of the expansion device, you have something minus temperatures. At low temperature, it is being and the pressure is being brought down. It's around something like a 1 bar. It says here. So here they are measuring something around some coil temperature, maybe a coil temperatures. So here inside that refrigerant, you will be maybe the temperature will be much lower. So here inside the cabin, it absorbs the heat. So you can see that the range of temperature inside the refrigerator, you can see something 2 or 4 degree maybe also present inside the cabin. And nearer to the coil, it will be around low temperature, maybe that is in freezer section. It will be the low temperature availability maybe that. This is the air temperature which is shown here. Okay. Then it absorbs the heat, and then it becomes when it comes in that refrigerant becomes nearer to the, even though if it is liquid, if it is at the exit of the evaporator, when it comes nearer to the compressor, it becomes vapor, because that the compressor is operating the generation of the heat available during the compression process, that the casing heat itself, it will make that refrigerant which is entering into the compressor into vapor. Fine. I hope you come across any other students that is can you brief about that is ideal cycle? Ideal cycle. What are the process available? Can someone interested? Okay, probably it will take some time. Okay, fine. Ideal process and actual process. These are the, just I want to communicate this one. See, the ideal process, which I can say that which if I am going by ideal process, I can have the maximum COP of the system. Here they will be referring that performance of the system is being represented by coefficient of performance in terms of COP. It will be called as. So here I can get a maximum COP if I am going by this process. That is all the four processes, that is isentropic compressions or isentropic expansions. If I am doing this, and as well as isothermal heat rejection, isothermal heat extractions, these are not possible generally. And if it is it is like a reversible process. If it happens like that inside my system, I can get the maximum performance of the system. That is the maximum COP I can obtain from the system, and equal to the ideal cycles. But in general, here you cannot reach the isothermal heat addition or isothermal heat rejections, as well as isentropic. This you can see there's a components, compressor, turbines, all these components. If I should go for these type of the components to obtain this process, which is practically it is, but theoretically you can get that one, but practically I need to spend a lot of the cost is involved, as well as the time, all those things being put up into this aspect to get the ideal systems. Okay, so that is practical one. You can see this. I have isobaric, that is constant pressure heat rejection and constant pressure heat additions. That two things will happen. And a compression may be the isentropic, it will be following the isentropic compression process. And the expansion process is only isenthalpy, where the enthalpy will be remained constant during the pressure reduction process. Enthalpy will be remaining, will not change during the expansion process. Here they will be using turbine in expansion device. Here for ideal process, here you can see this, it is an expansion valve they were using. That is, there are different types of expansion valve that is being put up into the practical system to get the pressure reduction, and where the isenthalpic expansion happens. Fine. So this is nothing but the variation between the heat pump and the refrigerator. So just the output matters. So why it is called as a refrigerator or why it is called a heat pump? It is nothing but the output. Output decides that whether it can be called as a refrigerator or the heat pump. Here you can see this. The record output is nothing but the here I want this cold refrigerated space is the required output I need to have. Okay, here in this this is the required output. Warm house is the required output, desired output which I need to have. So that decide the performance of this refrigerator or the heat pump. You can see the desired output by the required input. So it is a power plant. 8220. Can I proceed? Okay. Okay. Okay, fine. See, cooling effect that is divided by, so it is a power consuming device. This refrigerator or heat pump, water, maybe it is a power consuming device. So I need to supply energy to transfer the energy from the lower level to high level. Okay, so that gives this refrigerator and heat pump, and definitely that is a performance, that is COP of both the refrigerator and heat pump. So heat pump once again does nothing but it operates same as the refrigerator, but we have some reversing valve. See, condenser will be acting as an evaporator and evaporator will be acting as a condenser. That's the difference. So heat pump is exclusively useful for heating the room. That is the thing. And refrigeration or refrigerator, it will be exclusively to try, we are bringing down the temperature of the whole space or the product, whatever may be. Okay, that is the objective. heat pump objective is to heat the space which is needed, okay, for heating purposes. Heat pump, that is the purpose of heat pump. They will be having in addition to that component, four component, they will be having a reversing valve which does the functions. It will be reversing the flow, thereby the heating of the fluid happens, and that is that evaporator will be acting as a condenser and condenser will be acting as a evaporator. Okay, that's okay. Okay. I hope you have the compressors, different types of compressor it is being used. That is the positive and the dynamic compressors, which is been generally classified. Here they have all types of compressor is being used in R&DC field. That is rotary compressor, reciprocating compressor, centrifugal, and axial. Axial is not there, but in aircraft refrigeration, fine. Axial compressor has been put up in use. So different types of compressor. I'll show the diagram of the different types of compressors also. So in that positive displacement, what can someone say what is the difference between positive and dynamic compressor, positive displacement and dynamic type or non-positive displacement? I need to interact. Sometimes I may feel that students may know all the things, but I should not waste the time on the money. Positive displacement and non-positive displacement on the money. What is the main difference? How that pressure is being built up? Shivakumar irukkrara enakku help ku. Someone ella thoongitaangala enakku theriyala.
Dear participants, kindly share your views through chat box or otherwise unmute and then interact with our
something that can be also.
Okay, you can share your views, what you come across.
Okay, another half an hour you have to adjust with me. 1 hour they have given me.
The interactions is encourage the present.
See, whatever he knows, if you share, I can on that basis I can clarify that doubt. I can do that one. Someone please interact. Nothing, there is no marks. Nothing. Predetermined quantity of fluid is taken and compressed in positive displacement. So positive displacement and non-positive or dynamic compressors. I should put some name, otherwise.
So participants kindly exchange your views.
For 93 students, I don't know, something. And for 30 to 40 students will be there. Nariya strength sethittaru Sivakumar. Okay, someone, I should not point out someone. PPT, send the mail ID, sir. Arun Kumar. Idhukku solra. Okay, because why I need to put someone. Karthik G is available. Karthik G. Okay, no problem. Okay.
Yes, sir.
Karthik G, what is the positive displacement and non-positive? How I can differentiate? Can you respond?
Sir, no idea, sir.
Which year you are there? Which year you are?
Third year, sir.
Third year. Thermal subject you would have studied, no? Thermodynamics, thermal subject. Illiya? Thermodynamics, thermal. Illiya?
Yes, sir. Irunju.
Adala neenga adu compressor patti indha mari varalingla? It's not there. Okay. No, not based on the fluid directions. Okay, Karthik. Okay, no problem. Based on someone. Okay, fine. Okay. Kaviyarasan is there? Okay. Can you please explain about dynamic compressor? Okay. No, ISHRAE was become tension. Okay. Now explain but okay. See, positive displacement. See, positive displacement. Displacement is once again reducing the volume. Reducing the volume. Okay. Here the volume positive displacement type volume reduction happens when because of that the pressure rise is will occur. Okay, because of volume reduction the pressure is being built up in the positive displacement compressor. In dynamic compressor that is a non-positive displacement type, where a centrifugal force is being created, thereby I am imparting a momentum to the fluid, and in that momentum will be creating the pressure rise inside the pressure rise of the fluid, and when it comes out due to the cross section area, the variation in the cross section area also, that the kinetic energy will be converted into pressure energy. Mainly the dynamic means the rotor component will play a role in rising the pressure of the fluid, that is imparting the momentum to the fluid, and thereby and because of the variation in the area of cross section, the kinetic energy will be converted, some of the kinetic energy will be converted into pressure energy. This is how that dynamic or non-positive displacement, meaning to say that there is no volume reduction happens in dynamic compressor. In positive displacement compressor, definitely there will be a reduction in volume happens. Because of that volume reductions, that pressure rise will be done. Okay, fine. So these are some of the categories, that is scroll, screw, lobe or vane comes under where even the reciprocating, the rotary and reciprocating both these volume reductions. You can see the double acting or single acting water, maybe that reduction in volume happens because of the volume reductions, that pressure rise happens. Centrifugal and axles. I'll show some few. I don't have centrifugal. Okay, you know about the centrifugal compressors where you have the rotor will be present. Okay, fine. Compressor, and with respect to the throttling device, generally we have thermostatic expansion valve, automatic expansion valve, and capillary tubes, and something like float valves we have, and we have also electronic expansion valve. Can you someone say that what type of expansion device will be present in a household refrigerator or an air conditioner?
Capillary tube, sir.
Capillary tube, sir.
Super. Good. Okay. So capillary tube, because of its simple constructions as well as the cost of the product, the component is very less. Mostly it is being preferred in the small capacity applications where there is no need to have a load variations. Load variations in the evaporator side, there is no much load variation happens, means I can go for the capillary tube. So if there is an load variations is happening in the evaporator side, that is amount of heat that is being taken in the evaporator side. And those conditions under, they will prefer to go TXV, thermostatic expansion valve. Generally it is being preferred. Another one is constant pressure. Generally preferred is thermostatic expansion valve. And we have electronic expansion valves also present, where a precise control of fluid is being, the flow rate of the fluid is being done by the electronic expansion device. That is exact temperature I need to maintain in the evaporator. There I need to go for the electronic expansion device. But that is the latest one. Still, that because of the cost issue, and that is being brought into the, it is not been brought into the market, commercial market. Fine. So condenser and evaporators, once again, it's a constant pressure device. That is the process where happens, constant pressure process inside the condenser as well as the evaporator. There will be maybe an air cooled and maybe a water cooled, and sometimes in a larger capacity they go for the evaporative cooled condensers. Okay, preferred type of condenser maybe that is larger capacity and all, they go for shell and tube heat exchanger, and plate heat exchanger also. They were now been used in many industry process. And in small cap, not even larger cap nowadays, if there is a water scarcity, they go for the larger capacity system, air-cooled condenser, they are being preferred. Okay, in even the 5 to 10 TR capacity also, we have air-cooled condensers. Air-cooled condenser, because of it's mainly due to the maintainability. They are preferring the air-cooled condensers. That is fin and tube heat exchanger. Generally, it is been fin and tube heat exchanger is being taken care in the condenser type. Okay. In evaporator, once again the same thing, because it's a heat exchanger, no? Mostly in that is a shell and tube or plate heat exchanger, or directly we have the air or gas medium. Okay, fine. That is both are same, condenser and evaporator, but the function is the difference. Where the condensation happens in the that is heat removed from the refrigerant is happening in the condenser. Heat addition is happening in the evaporator side. So these are some ideas. So just I have put this slide to give an idea about that is what type of compressor I would be preferred for an this capacity. I can just give you some idea. You can see this one reciprocating. It is majorly, it is a matured process, matured compressor design. It has attained the matured compressor design stages. Reciprocating compressors. Mostly it is a hermetically sealed compressor they will be calling as in household application and all, or commercial application as well as also. They go for hermetically sealed compressors, where all the components will be motor, compressor, windings, everything will be present inside a casing. That is called hermetically sealed compressor. Okay. You can see this capacity they are preferring around something like around 20 tons TR they have preferred. We have, and something open type, it is a larger, for larger application they go for a higher capacity, and something other compressors like vane, scroll, screw, and centrifugal. This scroll compressor nowadays it is taking the market. Scroll compressor, once again it is coming under the low capacity compressors. You can see there's low capacity compressors, where this our household air conditioners, this scroll is been taking the advantage. Initially, previously it was reciprocating, which was dominating the market. Now the scroll compressor is been dominating inside the market. Okay, for residential applications as well as small commercial application, this scroll is being dominating. And the screw compressor and centrifugal compressor. Screw compressor exclusively for industrial purpose. That is processing food processing industries. No, they go for this screw compressors, compressors. And centrifugal probably they may go for exclusively for air conditioning application, larger capacity air conditioning applications like airport or malls, all those. No, in that area that the system will have a centrifugal compressor. Generally they have centrifugal compressors. Mostly it is a higher capacity system. When you go for higher capacity systems, you can see that starting capacity itself around something 100 TR1. So here they have mentioned, it may be the range may be different also. Something higher, if you go for higher capacity, they prefer the centrifugal compressor. Rotary compressor we have the option, but the cost of the compressor is very high. So generally in the market, this rotary screw compressor is being mainly the specific application they are being preferred. Fine. Just to have an idea about what are the compressors that is being put up in the market. Okay, something just to show a picture about the reciprocating compressors. This is the reciprocating in general refrigerant compressor looks, and you have the vane type compressors. Vane type compressor, you have, this is the you can see this is the cylinder, a small what is that, a rotor. You can see this is at the bottom a circle is being present. No, there this process happens. This process is happening. That is this is the rotary compressor. One is a simple operation. You can see this is the shaft and this is the piston. at the topmost right corner. This is the piston, and if something like sealing vane is present, where this and in between the gap, that is piston and the cylinder, this the compression happens. Compression happens. It is a simple arrangement. Vane compressor is a simple arrangement, and there is that is not a costly compressor also. It is when compared to reciprocating, it is still the cost is being very less to manufacture this vane compressor, rotary vane compressors. They will be calling it as rotary vane compressor. Just it will have some piston, rolling piston. It is a non-eccentric type, and you have the cylinder. Okay, in between this gap only the compression happens. Okay, the pressure rise. Okay, fine. And this is scroll. Previously we have seen rotary vane compressor, and now it is scroll compressor. Scroll compressor, you have two components. One is fixed scroll and another is moving scroll. Okay, moving scroll. This you can see that the top you have the this component is present. So one it will be fixed and another will be moved. It will be rotating. Now it will not be rotating. Sorry, it will be oscillating. It will be oscillating. The oscillation between the two scrolls, that's the function of compressions. Okay, you can see this initially the outer scroll and the gap between the two scrolls. You have some space is there where the here as I said, it is a positive displacement. Volume reduction happens. Okay, then the high pressure fluid is being moving into the next scroll, and then finally it is being discharged. Okay, this is the volumetric efficiency of the scroll compressor. It will be above 90%. Okay, above 90%. Because of that reason, this scroll compressor is being generally preferred. Okay, and manufactured somewhat slightly higher side of the reciprocating compared to reciprocating, it is slightly higher. The cost is higher. Okay. Here we have rotary screw compressor. Here also it is a positive displacement compressor. You can two screws. There will be, and you can see this compression and the two screws where the cross section itself. You have the variation of the cross section happen when the two screws mesh each other. There will be a variation of that is the cross section of the will vary when two screws mesh with each other. In that varying cross section, the refrigerant gas get compressed and it is moved to the higher pressure side. Okay, so the one screw will be called as a male lobe or something. Another one is a female lobe. Male lobe, that is male that is screw, will be connected to the motor. Okay. This is centrifugal. As I said, it is a non-positive displacement. You can see that there is a impeller which is present in the inside the casing, and this cross section area, this outer casing also will be varying. Okay, that is the impeller will be driven by the motor. Okay, fine. So wherever I need to go for a large volume flow rate, that is mass flow rate of the refrigerant I need to handle, I will go for the centrifugal compressor. Fine. I'm just sharing few information. Fine. This is magnetic bearing. Nowadays, this also comes into market. Magnetic bearings, the magnetic bearing oil-free compressors. Mainly this is screw compressor, and they are centrifugal. Oil is a major component that is coming into the cycle, so that if you are able to remove the oil, which is not only it is necessary for compressor, but other components like condenser and evaporator, if it gets settled, that heat transfer problems occurs. So to overcome that aspect, if I may be having the cost is not a factor for my side, I can go for magnetic bearing or oil free compressors. Okay, there is no oil is being recorded to that is during the running of the compressor. By it will be the bearing will be it will not be having contact with this that is sap. Okay, that kind of compressor is being coming into the market now, but cost is very high. So here that is to have a picture about this expansion valve, thermostatic expansion valve. Just showing you where based upon the load that is you have the sensing bulb will be present. It will sense the temperature. Thereby, according to that, the opening of the valve happens inside the expansion device. Okay. So whenever there is a high load, that is in evaporator side, I need to supply more amount of refrigerant into the evaporator sections. When there is the load reduction happen in the evaporator side, I'll be allowing only a little amount of refrigerant for circulation inside the evaporator. Okay, that's why they go for thermostatic expansion valve in the most of the when there is a very high variation of load happening in the evaporator sites. Okay. Yes, just to show you the how that plate heat exchanger is looking. It's one of the effectiveness of these heat exchangers. It will be around 95, 92, 97, and it will be there. The effectiveness of there will be some plates will be there where you have, they are called stainless steel plates. All are stainless steel plates where you have the corrugation will be happening between the plates. Because of that, the heat transfer capability of the fluid will be very high. Okay, the temperature difference between the hot and the cold fluid will be around 1 or 2 degrees only. Okay? That much effectiveness it will have. Generally, initially it was pre-PHE and all, the cost is very high. Nowadays, the cost has been brought down. Okay. So just showing the plate, how it looks. So I think I'm running out of time. Fine. I'll just brief about the refrigerant. What type of refrigerant is being put up in the market? Well, see, there is a first generation, second generation, third generation, like that it goes. Initially, they have something like a natural refrigerant. They are being preferred, and then they are moving to the synthesized refrigerants like CFCs, HFC, like that. They are moving, and then the third generation, they were once again they were saying that there is a ozone problem, and they were restricting some few refrigerants like 12, 22, like that, and then now they were moving into the global warming aspect. And they are saying that we have to reduce the global warming potential of the refrigerant. Thereby, they were dropping out few refrigerants. And now the next generation also, they are being brought up in the high efficiency. Now they are being focusing on the efficiency of the systems. Efficiency of the instead of low to GWP or ozone depletions, low zero ODP as well as low GWP. They were focusing on the efficiency of the systems. Okay, fine. So can you someone say what type of refrigerant is being used nowadays in air conditioners in market?
R134A.
Sachin, tell me. R134A. No, in air conditioners.
R22, sir.
R22. What are the other refrigerants?
R410, sir. 410A.
Super. 410A. It is been. It is a mixture of 32 and 125. It is a high pressure refrigerant, and it is been now brought up into the most of the air conditioning like Daikin 32. They were being sometimes being used. Otherwise, they go for 410A. R32 or 410A, and now the propane also comes into picture. Some, and even this propane is also being Godrej refrigerator. Propane is being put up into the air conditioners. Propane only, I think I known company. Godrej is being using the propane as even though it is a flammable. They are designed in such a way that safety aspect has been considered. Fine. So in air conditioner, in a refrigerator, previously it was 12. Now they have moved to the 134A, and still they are from 134A. They are moving to the 600A or HC blend. 290 plus 600A. That is being now at present scenario it is being, but still R134A is being preferred. And even though this 134A or 22, they have the ZWP, high ZWP, they will be phased out. They will be phased out in few years. Okay, fine. So that's to have an idea about the refrigerant. You can see this 32 704 ZWP, that is 700 times it is able to destroy the ozone molecules. That is, the ZWP represents the how much times the respect to the base value. That is, if this CFC11 is being taken as 1, and this, if it is 32, I am saying that 700 times it is able to affect that global warming aspect in this atmosphere. Okay, like that we have to mean. So you can see this. There are some few refrigerants that is very where we have low ZWP, something like 1, 2, 3, 4 YF. This is an olefin category, olefin category. It will comes under hydro HFC or olefin category. 1, 2, 3, 4 YF, and another ZT they are having. This is been DuPont. They are just producing it, but still they are claiming that is very GWP. But still, it is been introduced for few years, few back years, 5 years before also, I think so. But still, it is not been commercialized because of its cost. Okay, 1, 2, 3, 4 YF. It is being put up for the refrigerator or in replacement of 134A. And okay, this 410A, you can see this 32 plus 125, something 50. It is a mixer, and it has the ZWP. But when compared to other that is like a 22, you can see something like a 1000. 22 it has 1780 here they are representing, and here 410A something like 410A 2100. Still it has the ZWP. Okay, but now in Indian we have 410A or 32 is being utilized in the air conditioning applications. Okay, fine. Here propane and isobutane. These are some other. Couldn't get you.
Presentation not visible, sir.
1 second. Okay, tell me. Can you put it in the chat?
Please.
The screen is still visible to others. No. Any questions from your side or any doubt, clarification?
No, sir.
Sachin, anything to be from my side? I have to.
No, sir. Presentation not visible, sir.
Sir, please pin sir presentation. Now it is visible only. Sir, please proceed, sir.
Okay. Thank you. Sorry, okay. Some of the natural refrigerants, that is ammonia, water, carbon dioxide. These are the trend now. These are the trend future refrigerant that is being working on. Ammonia, carbon dioxide. Yeah, high Benz Carla. Foreign they were using carbon dioxide as a refrigerant in cars carbon dioxide CO2 refrigerant. It is being put in market, taking up the markets. Okay, and that is supermarket refrigerations also. They were having the now the carbon dioxide is being marketed by Danfoss. Okay. So ammonia is also another category. Natural refrigerant, they doesn't have any, like they have less GWP as well as there is no ODP will be present for this. Okay, fine. So these are the now at present situation we have this one. So these are something like you can see there's some short term or long term refrigerant which is being preferred as on date. Okay, something like air conditioning, you can see 132 is in there. Something 290 propane is being used in automotive. 1, 2, 3, 4 YF is being put up in the market, and freezing application something like ammonia Our water is being taken 717 and 744. CO2 is being there, and refrigeration side, domestic, commercial, industrial, they have the long term 290. As I said, no, 290, 600A. That is the future. Now it is been 134A. The future will be to 290 or 600A, or sometimes 1234YF. Fine. Some category where they are being applied, these refrigerants. These are refrigerants where it is being applied. Something in mobile AC, stationary heat, and with respect to the temperature as well as the cooling capacity, they are just shown this one. And this, as I said, the title gives us some recent trends. I just want to focus another 10 minutes. I can take another 10 minutes, and then I will move on to questions. Okay, mechanical cooling system, that is a solar air conditioning only nowadays the talk of the something like that, where everything with respect to, we are not going for conventional systems nowadays. They were moving to renewable systems, something like that. Mechanical cooling systems and thermally driven systems. So mechanical cooling system, once again, vapor compression system is run by the PV module. That is called mechanical cooling system. Thermally driven system, in air, if I am having some heat, additional heat from my, that is extra heat is then available, then I can run this system, thereby producing the cooling effect. Okay, there I have absorption, AB, absorption, AD, absorption, as well as desiccant. Another one is we have ejector refrigeration system. We have this one. Okay, fine. So something to have an idea about some collectors which is being used to produce the heat. Thereby, if I am able to heat that at that temperature, I am able to do the cooling purpose. Something here it is the collectors and temperature I can just interpolate, where I can go for something heating and crop drying purpose, some space heating applications or water and space heating, space cooling applications, industrial process heating. So I need to say that flat plate collector can be used in these small applications like pool heating or crop drying. If I want to go for the concentrated something, I don't know about you are aware of these collectors. Fine. Concentrated parabolic collectors or evacuated tube collectors is nothing but thermal collectors. I'm just absorbing the solar heat. Okay, with this collector, there if I'm having with the help of those collector, I can do for the space cooling application also. I go for some concentrating application, concentrated collectors. We have I can even produce the power with the help of the energy which is available from the concentrating collectors. Okay, I can generate the steam and directly run the power plant. Okay, fine. So where something like you have different types of collectors: flat plate, evacuated tube, concentrated or compound parabolic collectors. You have, and you have different types of collectors are available, and with respect to the collectors, the temperature is also varying. Temperature will be varying. Okay, where up to that temperature I can able to generate the steam or the fluid which is flowing. No, I can reach the temperature with those collectors. By having that heat energy, I can run my cooling system or generate the power. That is the motive behind this one. Okay, fine. You can see this here. I have PV module. If I am having a PV module, thereby I can generate the power through the PV modules. Nowadays, that is DC compressor are being coming into the market, where the current produced from the PV module DC can be through the charge controller. I can directly with the help of an electronic unit, I can run this compressor. Thereby, I can maintain the cooling inside a refrigerator. It is been coming into market. Future is like this one. With the help of PV model, you can run. You have to run your own refrigerator. Okay, but still it is what is that? It is not been marketed, but these are being trial basis. They are being running. It is being done. Okay. But all the components are available now. It's up to us to decide how to design these modules with along with the refrigerator. Simply by with a small configuration, I need to sell it. Okay, if it is done, you will be a big businessman in this one. That is, we have to plan. Okay, fine. This is once again heat energy is being utilized for the desalination purpose. That is one collector they have. It is in a flat plate collector once again, where I can even so one application I'm just putting up in this slide, where I can do the desalination purpose also. Okay, these are the trends now. It is being going on. Okay, fine. So this is vapor absorption systems, which component is missing in this? Can someone say that? Which component is missing in this one?
Compressor, sir.
Good. Fine. This compressor will be replaced in this vapor absorption system. I need some waste heat energy. That is enough to run the systems. Okay. Fine. If I'm able to get the waste heat energy from the solar collectors, I can run the systems. Now it is being marketed. You can see this here. Initially, it was being a big components like all the heat exchangers or the cooling towers. It is been something like heat exchangers. All these components like generator, absorber. I'm sorry to without lack of time, I'm not able to explain this working principle. I'm just skipping many technical things. This generator, all the larger component. Now evaporator currents are all the larger component. Now due to the manufacturing aspect as well as the heat exchanger configuration we have and the design aspects, because of that you can see that they have been brought down, scaled down. I can have some 5 tier capacity absorption systems. Here I need only what is waste heat. You see, this unit will have something like outlet pipes will be having. Okay, where I need to supply some heating fluid. I'll be getting some cooling outlet. I'll be getting it, and something for condensation. I need some inlet and outlet. So 1, 2, 3 pipelines sets I need to have. If I am having this, I just I'll put up my this unit into my room and do some cooling purpose. I no need to go for the power which is required to run the like mechanical vapor compression systems. This unit can be put into your room, but slightly higher costs. I have to spend initial investment. I have to go high. Okay, on the money. So another one is steam jet refrigeration systems, where whenever there is a waste steams are available. Otherwise, if some solar collector, I am able to generate the heat. Thereby I am able to generate the steam. I can go for the steam jet refrigeration systems. Basically, it is nothing but evaporation process which happens thereby the reduction in the here they have 2 drums. You can see there's 2 drums have been present, where you have a high motive steam is necessary for operation of these systems, where I am generating some low pressure in the ejector side. Here you have this ejector where I am creating a low pressure, thereby the water molecules which is present in the drum will try to evaporate the water which is present in this drum. So okay, the molecules which is present at this drum will be trying to evaporate, and that evaporate happens, this liquid will be trying to get cooled down. So the low temperature liquid will be taken for any air conditioning purpose like that. Okay. So he can see this, see here that the components they have been mentioning it, something like a ejector, I need to have some ejector, I need to have some evaporator and condenser, 2 drums are enough. Okay, this is also in market, now it is being put up, but cost it is different. Okay? We have to think of that cost. It is only inlet and outlet connections. If I have steam, fine, I can produce the cooling. You can see that they have shown this company have given you some 100 kilowatt, 50 kilowatt, even 15 kilowatt, something like a 5 TR capacity, around 5 TR capacity. It is been available. I'm saying that one. Okay, ejector refrigeration or air conditioning systems. Okay, fine. So here, addition to the absorption, you can see here also I have just a company called Fahrenheit ESIA. That is, they have been developing this absorption cooling, absorption refrigeration system, where they have the absorption as well as 2 working pair will be there, something like geolite water, silica gel water, activated carbon ammonia, calcium chloride methanol. So these are the working fluid and these are the adsorbent, ADSOR, adsorbent, BENT, adsorbent. Okay, so what this is the cycle they have, the process which is happening like heating and pressurization, desorption and condensation, cooling and depressurization, adsorption, evaporations. A continuous cycle can happen. The main drawbacks is after few years that the absorbing capability of that the zeolite or silica gel, whatever it will be reducing. Okay, there the system gets what is that the required the cooling performance cannot be uptime. That is the thing which happens in the as and did the drawbacks which we have in the AD absorption refrigeration system. Now this is for your reference, saying that small capacity systems are being brought up in the market. Absorption chillers are there. We doesn't know here also. Once again, I need the only heating that is heat energy, that is high heating fluid is enough to run the systems. Okay, which can be collected from the collectors. Fine. So another one, final one is desiccant. Actually, the difference is the absorption and here the desiccant is mainly this desiccant system is being used for air conditioning applications, mainly to conserve energy. This desiccant system is being brought into the market. You can see there are the different types of that solid desiccant as well as a liquid desiccant which we have. Like silica gel and zeolite are a common desiccant material that will be present in the desiccant wheel. Here you have the desiccant wheel, that is desiccant wheel, mainly to reduce the load of the main system. That is the what happening in the desiccant systems, mainly to reduce the load. Thereby, I can save the energy. Okay, that is the basic behind the going for the desiccant systems. Okay, so many advantages we have. That is high energy saving. Cost is different. High energy is mainly the energy saving they are looking for, and you'll also we are not going environment friendly like conventional refrigerant. We are not going for this. In fact, there is no refrigerant has been present in these systems, and air filters operation close to the atmospheric pressure. You can see this maintenance cost, all those have been coming. Okay, fine. There are different ways of clubbing the things now. In foreign countries, the systems are running like clubbing PV flat plate collectors or concentrated photovoltaic, concentrated PV collectors as well as evacuated. Different types of collectors are there. PV modules is being clamped to generate the power, that is trigeneration. I can generate heat for process industry, I can generate power for any applications, I can generate the cooling effect through absorption or adsorption or anything. I can, like that, the integrated systems are being developed now. Integrated systems are being developed. Okay, fine. Something to know about some different types of systems available. that is we have, and advantage and disadvantage. I have shared this slide to the your Sivakumar sir, then you can get it from me, and some
Yes,
from the reference which I have gone through from these PPTs.
sure,
My
sir.
email ID and the number will have this. Anything you can communicate through the your Sivakumar sir. Okay, fine.
Sure, sir. Okay, sir.
Now I need some. Sivakumar, can I take another 5 to 10 minutes?
Yes, sir. And by this time, let us interact with our participants.
Definitely, I have to interact.
Yes, sir. Yes, sir. Dear participants, kindly post your questions through the chat box. Otherwise, you can unmute and then discuss with our respected resource person, please.
Whether it was useful to you students, நான் பேசுனது ஏதாவது யூஸ்ஃபுல்லா இருந்துச்சா இல்ல விஷயம் பண்ணிட்டேன்.
Yes, sir.
Yes, sir.
இன்னும் கொஞ்சம் கம் பண்றீங்களான்னு நினைக்கிறேன் என்னுடைய presentation. Fine. So some questions I need to have. Otherwise I'll ask you question. நான் அப்படிதான் பிளான் பண்ணி வச்சிருக்கேன். நீங்க கொஸ்டின் கேட்கலாம், நான் கொஸ்டின்.
Yes.
Okay, உங்க சைடுல வரணும்
Sir, in the chat box, a question is raised by Karthik ji. What is mobile AC?
No, that is nothing. அப்படிலாம் ஒண்ணும் கிடையாது. Mobile AC. There are also the 4 component comes into picture. So there are different types of compressor is entirely different. It is not a scroll compressor or reciprocating or anything like that. Swash plate type compressor or a variable displacement compressor is being used in the mobile air conditioning. And the marida. But other things like there are different types of orifice tube is being used in the as an expansion device. And compressor and condenser and evaporator are same. Condenser and evaporator, that is types is different. That is a flat tube they have, but everything same. What are the working principle are same. There is nothing difference. And there the car AC they were going for 134 air refrigerant, and now they were market in foreign countries they were going for CO2. There is no much differences in operations. Feedback கொடுக்குறாங்க effect on ozone depletion number in the refrigerant. That's what they were. See, CO2 they were giving GWP as 1, and they are referring to that. From that reference they were saying that GWP of the refrigerant which they are synthesized is this much. அந்த மாதிரி சொல்றாங்க. It gives an idea about if the ODP is, if I am saying that ODP of a number is being said that like 100, 300. So 300 times it is able to sustain in the atmosphere and able to do that operation of depleting the ozone layer. That is the main. It with respect to the number of years it will be decided. How many years it may be living in the atmosphere and able to do the job. Nowadays there is no ODP is 0. All the refrigerant which is coming into the market, 0 ODP. Or natural refrigerant they go for. And any other questions, Sivakumar? நீங்க தான் கேட்டிங்களா?
Yes, sir.
Okay. வேற யாராவது students நினைச்சேன். Fine.
Dear participants,
அவங்க கேட்க மாட்டாங்க.
kindly post your question.
In a few questions I am expecting. Yes.
Maximum COP achieved so far.
That depends. See, once again, as I said, that desiccant systems are those systems are there. I think 0.5 or 0.6 and the marida below its one. And in this refrigerator and all, pathingla something around 2 or 2.5 COP and the mari kedikudhu and the mari solranga. And air conditioning also is the same thing. That is they have in refrigeration I have more COP when compared to air conditioning systems. Something like 2.0 and then between 1 to 2 or 3 and the range now. But for this absorption system and all, adsorption, desiccant, idella very less. That is below 1 and the marida COP will be and the marida irukku. It depends upon the system. And the marida irukku.
Yes, thank you, sir. So any questions from the participants, please post it.
I think time out. I am taking much of the time of the students.
Yes, sir. Yes.
ஐயோ சாரி, ஒரு மணி நேரத்துக்கு மேலே அடியை போட்டுச்சா, பேசக்கூடாது, அதை கட் பண்ணிக்கலாம். ஃபைன்.
Thank you, sir. Thank you, sir. Thank you very much, sir.
I thought of sharing some quiz, not quiz. See, someone can answer this. Okay, I'll just put some questions. So, okay. Easy. So can you someone இதுவும் the air conditioning side வந்துருச்சு, sorry, something. So I think this is a, so aircraft refrigerants is most commonly used in which one? Air cycle refrigeration system is most commonly used in. Someone can give the answer? Just over a few minutes. I want to hear the voice of the students. அதுக்காக.
Sir,
aircraft air conditioning system, right? சரி, ஓகே. விடமாட்டேங்க. ஓகே, கெமிக்கல் ஃபார்முலாலாம் வேண்டாம். Okay, this one. Okay, which is a long-term alternative for car air conditioners? Which is a long-term alternative refrigerant to car air conditioning? In this 4 option. தெரியுமா, வாய்ஸ் தெரியுமா? பேஸ் சிவகுமார் மேட்ச் ஆன்சர் பண்ணுமா ஏதாவது?
Yes, sir. Yes, sir.
யாருமே இன்ட்ரெஸ்ட் இல்லைன்னு நினைக்கிறேன்.
Yes, students, put answers here.
Which one is the longest alternative refrigerant in car air conditioning? Car air conditioning பத்தி நான் நடத்துனேன்.
CO2, sir.
Right, CO2. This is halide torch. Okay. This one, centrifugal compressors are used in.
Sir, large refrigerant capacity system.
Super, thank you. Good.
Well done.
இதுதான் ஈஸியானதுதான். Which is the following not positive displacement type compressors?
centrifugal compressor, sir.
Okay, good. Super.
Good. Well done.
சிம்பிளா ஏதாவது டக்குன்னு படிக்கிற மாதிரி பார்க்கலாம். இதெல்லாம் வேண்டாம். Okay, another last question I will just put up. சரி, ஓகே. இன்னொரு நிமிஷம் ஆசை பசங்க. Okay, இதுவும் தெரியும். Fine. This is a 410A. Okay, fine. Okay, can someone give the answer? At present, the reciprocating chamber most common as they are. At present, the reciprocating compressor are most common as they are.
Sir, low pressure required.
What is the answer? Comparatively easy to manufacture. Low pressure, no, what you said, that low power required? No. It is mainly actually this reciprocating compressors. It is a simple piston and cylinder arrangements. That's it. So in this 4 option, this is the best one. Comparatively easy to manufacture. Okay.
Okay.
Okay. Thank you. I think we have to close with this one. Sivakumar Adichuru.
Thank you, sir. Thank you.
Okay. Propane. Okay, thank you.
Thank you, sir, for
Thank you. From my side, I'm just closing my thing.
thank you, sir, for
Any
clearing all
interaction
the
which
doubts and queries.
students can have through mail or some they can call me, no issue.
Thank
Okay.
you, sir, for clearing all the doubts and queries.
Thank you, Pa.
In graduate session, they said, I invite Riju Kumar from final year mechanical to propose the vote of thanks.
Thank you, sir.
I feel very honored to propose the vote of thanks
Thank you, one and all,
to
presenting for coming into the session. Shall I close, Sivakumar?
Just a minute, sir.
Ah,
Yes, sir.
ah.
Yes. Dear student, so okay.
hello, hello.
Yes, your voice is reachable. Yes, please proceed.
Good afternoon.
One question, Sivakumar, 1 second. Someone has posted me, is there any new ways to reuse the refrigerant from old R&D
Yes,
system instead of releasing into the atmosphere?
yes, sir.
I actually, the pure refrigerant can be reused, but mixer, that is 410A and HC blend, those cannot be reused. Pure refrigerant can be reused and mixer cannot be reused.
Okay, fine, sir.
That is the thing.
Okay.
Any other questions on when
Uh,
we are replacing the refrigerant in conventional VCR system? What about the suitability of the compressor? So we need entirely replace or any changes. So it is depend mainly the refrigerant which we are going to change. No, we have to see the vapor pressure of the replacing refrigerant. Based on that only, it has to match. The alternative refrigerant has to match the vapor pressure of the existing refrigerant. Then only if it is matching, I can go for the same compressor. Otherwise, I need to see that's what R22 and 410A, that doesn't match. Entirely different. It is a high pressure refrigerant. 410A, R22 is a low pressure refrigerants when compared to 410A. So we cannot replace the compressor. Okay? We need to go for new compressor only on the mine. Mainly it depends upon the pressure, vapor pressure of the refrigerants. Okay.
Thank you.
Those are the few
Richard
questions
Kumar?
that has been posted. Thank you.
Thank you, sir.
Sorry,
Richard
sorry
Kumar,
for
please
interrupting.
proceed. Mm.
Good afternoon to all. I feel very honored to propose the vote of thanks to
அது
everyone,
கேட்கல.
everyone present here for the webinar on basic and recent trends in refrigeration and air conditioning, organized by our Department of Mechanical Engineering in association with RIT-ISHRAE, RIT-IE, RIT-EIC of Tropical Institute of Technology, Rajabalam. Uh, I wish to begin by thanking today Dr. P. Balachander for enlightening our knowledge in the field of refrigeration and air conditioning. Sir has explained about refrigeration fundamentals and today trends in the refrigeration system with the active interaction. Thank you, sir, for your thoughts and the insights. Uh, we all are inspired by your words. I also would like to place on record our heartily thanks to our management, Principal Dr. L. Ganesan and Vice Principal Dr. S. Rajakarnagaran for their support towards this endeavor. My thanks goes to student coordinators, Mr. Magadevan and Mr. Vinod, faculty coordinators, Mr. N.L. Sujin and Mr. J. Jebin, and convener Dr. V. Sivakumar and the organizing team for their support and guidance in conducting this webinar successfully. I finally extend my thanks to participants from Ramco Institute of Technology and the external participants for the interest and the cooperation in conducting this webinar in a fruitful way. Thanks to all.
Okay. Thank you, Richard Kumar. Thank you, sir. Balachander, sir.
Thank you, Sir Kumar. Thank you.
Thank you very much, sir. So the way of ending is what you had a fruitful assessment also. Okay, how much of the students are involved and
Ah,
everything is assessed. This is the way of our College of Engineering India 9 stage.
okay.
Thank you, sir. Thank you very much for your in a busy schedule.
Yeah.
you have spent some time with our students, sir. We are working with low cost cold storage plants, sir. Myself and Mr. N.L. Sujin, sir. So related to this, we are going to have a fruitful interaction with you, sir, in your
Fine.
convenient
Okay.
time. We will get a proper appointment and we will discuss about you, sir.
Okay. Okay, sir.
Thank you very much, sir. Thank you for your moral support and guiding the students of RIT
Thank
to
you.
interact with such kind of webinars, sir. Thank you very much, sir. Thank you.
Thank you. Thank you. Thank you, Sukma.
Thank you, sir.
I'm leaving now. Thank
Yes,
you.
thank you, sir. Thank
Thank
you.
you. Thank you. Bye.